In AP Calculus, you'll be expected to have these two quotient identities and these three Pythagorean identities from trigonometry memorized. Now, most students can remember sine squared plus cosine squared equals 1. If you can remember sine squared plus cosine squared equals 1, let me show you a little trick you can use to build these other two identities. Watch what happens if I take my sine squared plus cosine squared equals 1 and I divide each term by sine squared. Well, sine squared divided by sine squared is of course 1. Cosine squared divided by sine squared is cotangent squared. And of course, 1 divided by sine squared is cosecant squared. As you can see, if you can remember sine squared plus cosine squared equals 1, it's quite easy to uncover this identity. Now watch what happens if I divide every term by cosine squared. Well, sine squared divided by cosine squared is tangent squared. Of course, cosine squared divided by cosine squared is just 1. And 1 divided by cosine squared is secant squared. If you can remember sine squared plus cosine squared equals 1, you can build either of these identities.
This is our second lesson on solving trigonometric equations, and before we get started, I'd like to take a look over here. I'm hoping you know how many correct solutions this equation has. It's a quadratic equation. It should have 2 correct solutions. 0 is 1 correct solution, 0 squared is 0, and 3 times 0 is 0. And positive 3 is also a correct solution. 3 squared is 9, and 3 times 3 is 9. And the reason I'd like you to look over here is I want to point out to you that if you divide both sides by x, sometimes students feel that they can divide both sides by x. And there's no doubt x squared divided by x equals x, and 3x divided by x equals 3. But what I'd like to point out to you is that when you divide both sides by the variable, you lose one of the correct solutions. We're only getting 3, and we just saw a moment ago that 0 and positive 3 should work. When we solve quadratic equations, we like to gather all of the terms on one side. I would first subtract 3x to both sides, and then I could factor the left-hand side. Now I have 2 linear factors that multiply for 0. I solve this by setting each factor equal to 0. So here we determine that x equals 0, and here we determine that x can also equal positive 3. All right, I bring that to your attention because over here, the first thought that might pop into your mind is to divide each side by cotangent of x. But if you divide each side by cotangent of x, you're not going to obtain all the correct answers. Let me instead begin by subtracting cotangent x on each side. And what we now need to do is see that this term has a cotangent of x in it, and this term has a cotangent of x in it. Therefore, we can factor out a cotangent of x. We now have 2 factors that multiply to make 0, so I'll set this factor equal to 0, and I'll set this factor equal to 0. Now, cotangent of x is not one of our primary trig functions, so I'm going to rewrite this. If cotangent of x equals 0, well, that means cotangent of x equals 0 over 1. Tangent of x would be the reciprocal of that, and the reciprocal of 0 over 1 is 1 over 0, or undefined. To solve this equation, I'll add 1 to both sides, and I'll also divide 2 on each side. Since this is cosine squared of x, I'll need to square root each side as well. The square root of cosine squared is of course cosine, and the square root of 1/2 is positive and negative square root of 1/2. I can rewrite the square root of 1/2 as the square root of 1 over the square root of 2, but of course, the square root of 1 is 1. I need to do one more thing before I go spinning around the unit circle. I need to rationalize the denominator of this fraction. I'm now ready to go up to my unit circle and find my answers. Tangent of x is undefined. Well, which angles have a tangent that's undefined? Pi over 2, tangent of pi over 2 is undefined, and 3 pi over 2 is undefined. And let's also go find where cosine of x is both positive and negative, radical 2 over 2. Well, pi over 4, cosine of pi over 4 is positive radical 2 over 2. Cosine of 3 pi over 4 is negative radical 2 over 2. Cosine of 5 pi over 4 is negative radical 2 over 2. And finally, cosine of 7 pi over 4 is radical 2 over 2. This trigonometric equation has 6 correct solutions. I'm going to approach number 2 in a very similar fashion. The left side is a trinomial. Let me express this trinomial as the product of 2 linear factors. And now that I've factored the trinomial, I'll set each factor equal to 0. Over here I need to subtract 1 and divide 2 to each side. And here I need only add 1 on each side. Now we're ready to spin around our unit circle and determine where sine of x equals negative 1/2. Well, here I see sine is positive 1/2. Here it's positive 1/2. Here we go. Sine is negative 1/2 at 7 pi over 6. Sine is also negative 1/2 at 11 pi over 6. And we need to see where sine of x equals 1. Well, sine of x equals 1 right here at pi over 2. This trigonometric equation has 3 correct solutions. The first thing I see we need to do in number 3 is set it up by factoring by gathering all of the terms on one side of the equation. Let me start by subtracting 3 to both sides. Now this is going to be a little bit trickier to factor than the first 2 examples. We can't factor it like we did in number 1. There's nothing we can pull out of all 3 terms. And we can't factor it like we did in number 2. We can't use 2 binomials because we have a combination of trig functions. We have sine and we have cosine. I'd really like to first rewrite this equation using only sine or cosine. However, it can be a little bit tricky turning a sine expression into a cosine expression or a cosine expression into a sine expression. The only way I can do it is by utilizing my Pythagorean identity, sine squared plus cosine squared equals 1. Let me subtract cosine squared to each side of this identity. And what I'll now do is replace sine squared x with 1 minus cosine squared x. I'm replacing sine squared with 1 minus cosine squared. Now my equation is written only using cosine. Let me distribute this 2 to each of these terms. And these terms now certainly need to be rearranged. I think I'll gather them all on the right side. So my negative 2 cosine squared x, when I move it over to the right side, will become positive 2 cosine squared x. Let me also subtract 3 cosine x over. And I need to add 3 over and subtract 2 over. Well, if I add 3 and subtract 2, I'll get positive 1 on the right side. And I'll be left with nothing on the left side. Now, all my terms are gathered on the right side. The left side equals 0. Now I can factor this trinomial. Now we can just set each of these factors equal to 0. Here I need to add 1 and divide 2 on each side. Here I need only add 1 to each side. And now we're ready to spin around our unit circle and gather up our answers. Cosine of what angle equals 1/2? Well, cosine is 1/2 here at pi over 3, cosine is 1/2. And down here at 5 pi over 3, cosine is 1/2. Cosine of x equals 1 in only one place, right in the beginning at 0 pi. This trigonometric equation has 3 correct answers. In number 4, I want to once again use the strategy of rewriting it using only one trig term, but this time it should be easier. Cosecant of x is equivalent to 1 over sine of x. So I still have 2 sine x minus cosecant of x. Let me apply the McFarlane method of adding and subtracting fractions. I know a fraction minus a fraction equals a fraction, and my new denominator, I just multiply the denominators. 1 times sine of x is sine of x. Sine of x times 2 sine of x is 2 sine squared of x. And then take away 1 times 1 is 1. This all equals 0. And of course, whenever I have a fraction equals a fraction, I can cross multiply. 0 times sine of x is 0, and 1 times this numerator, well, this is just 2 sine squared x minus 1. Let me add 1 to each side and divide 2 on each side. And seeing as it's sine squared of x, I'll now square root each side. So sine of x equals the square root of 1/2. Of course, we need to indicate positive and negative, and the square root of 1/2 is the square root of 1 over the square root of 2. And this should look familiar because we saw one like it just a moment ago. The square root of 1 is 1. And if I rationalize the denominator, 1 over radical 2 becomes radical 2 over 2. So let's go to our unit circle and see where sine is either positive or negative, square root of 2 over 2. Sine of pi over 4 is square root of 2 over 2. Sine of 3 pi over 4 is square root of 2 over 2. Sine of 5 pi over 4 is negative square root of 2 over 2. And sine of 7 pi over 4 is also negative square root 2 over 2. This particular trigonometric equation has 4 correct answers. Number 5 looks a little tricky for a few reasons. One reason is we have a combination of trig expressions. We have sines and cosines, But if you look more carefully, another thing we have a difference in is we have a single angle x and a multiple angle here of 2x. Perhaps we can utilize one of our double angle formulas to replace sine of 2x. Sine of 2x is equivalent to 2 times sine of x times cosine of x. All right, we may still have a variety of trig expressions, sine and cosines, but at least we have all single angle x's. I notice the left side of my equation has 1, 2, 3, 4 terms, and we have a technique we can use to factor a 4-term polynomial. Let's try factor by grouping. Notice these first 2 terms, I can pull a 2 and a sine x out. So this would be 2 sine x times cosine x plus 1. Here, watch. 2 sine x times cosine x is 2 sine x times cosine x, and 2 sine x times 1 is 2 sine x. Now, it's been a little while, but recall when we use factor by grouping, we need to duplicate this cosine x plus 1 again. Is there something we can multiply times cosine x and positive 1? Oh yes, negative 1. Negative 1 times cosine x is the negative cosine x, and negative 1 times the positive 1 is negative 1. My next step in factor by grouping is to group the factors into the product of 2 factors. My first factor is 2 sine x minus 1. And my second factor is this duplicate. This is cosine x plus 1. You can even check it. Let's FOIL here. 2 sine times cosine is 2 sine cosine. 2 sine times 1 is the 2 sine. Negative 1 times cosine x is negative cosine x. And negative 1 times positive 1 is negative 1. We're ready to proceed. Let's set each of the factors equal to 0. Here I'll add 1 on each side and divide 2. Here I'll subtract 1. And we're now ready to look on our unit circle. Where is sine equal positive 1/2? Sine is positive 1/2 at pi over 6, and also over here at 5 pi over 6. And where does cosine of x equal negative 1? Only here at pi. This trigonometric equation has 3 correct solutions.
Okay, time to go complete your tries.